All right. So a couple quick things. Test is Thursday. You're allowed a index card, 3x5, 4x6 is fine. You can use both sides of the index card. It has to be handwritten. So nothing like stapled to it, pasted to it, whatever it is. You are allowed to use your calculator. You're allowed to use your phone for the standard deviation calculator and stuff like that. That's not a problem. It's going to be 7 questions, just like the review test. So it shouldn't be, you should be able to finish it, no problem, in the amount of time that you're going to have. I'll be here at 9 o'clock. So if you want to get here a little early, as soon as you come in, you can start your test. I think that's it. Any other questions on the general test and how it's going to go? Yeah.
So if we were to come in at as early as 9 o'clock, could we study a little bit before you give the test, or will you give the test as soon as?
I won't answer any questions, but you're more than welcome to come in and study. Just tell me when you want the test.
Okay.
So because other people are going to start the test, so I really can't answer questions at that point. But yeah, you're more than welcome to study and stuff before you're ready. Any other questions? All right, let's go over the review. So you notice each question had the number of points for it, since each question's worth a little bit differently based on how much work and stuff you have to put into it. Like this one's worth 8 points, so each question, in essence, is worth 2 points each for this because there's 4 parts to it. This one's asking you to determine if the data is qualitative or quantitative. If it is quantitative, state if it's discrete or continuous. So basketball free throw percentages, is that qualitative or quantitative?
Or quantitative.
That is quantitative. Is it discrete or continuous?
Continuous.
That is continuous. So see if I can get my thing to write to me. Yeah, there we go. So A is and continuous. Good. The number of cars that a family has, quantitative or qualitative? Quantitative. Is it a discrete or continuous? Discrete. So this is also quantitative, but it is discrete. Color of pants students wear?
Qualitative.
Qualitative. Very good. And that one you do not have to tell me if it's continuous or discrete because it can't be. Bank account balances, qualitative or quantitative?
Quantitative.
Quantitative. Is it a discrete or continuous? The wonderful debate.
It can be either discrete or continuous.
It actually could be either one. All right. It is quantitative. So it really depends on how you look at it. Like normally a bank account balance ends in cents, so therefore technically it's discrete because you're not going to have a half a cent. However, if it depending on what kind of bank account, like if it's a savings account, stuff like that, you do earn interest on it, and they actually do keep track of those because that actually can make a difference when you're doing compound interest. So technically, whichever one you put down, I'm going to give it to you as right because they're both correct in that situation. So I will give it to you for either one of those two. All right, so that's that one. So obviously the first question is going to be very similar to that. It's just going to have 4 different things I'm asking you for. So, all right, this one. Depending on how you looked at this test, this probably was the one question that screwed you up the most. Because actually it's asking you how you would do it. There's a lot of different answers that you can give for this question. So you're given a list of 751 students at a local high school. You need to get a random sample of 40 students to survey about the conditions of the high school. You're given the following information. So there's a whole bunch of characteristics of the school. How would you like to get a random sample of the students? So this is one of those questions that there is not one right answer. Okay? It really depends on how you explain what you're going to do. And that's why it's worth a little more points, because it's a little more work behind it. So what are some ways that you can get random samples? Yep, you can get a random number generator and just select 40 people out of 751. Would probably not the best way to go. So that's the thing. It's like there's tons of right answers. It's how you explain it. So yes, that would be work. Now, how would you explain that would give you a good representation of the class? So that's the question. Now, you do not have to use all of this information. If we're looking at conditions about the high school, so we got the random number sample, and you have to explain why. What's another way that we can collect that data? Cluster sampling. Okay. So how does cluster sampling work? Okay, so you're basically basing off. Now that's literally where the data and stuff comes into play, right? So now you have to figure out which one would you like to use. You don't necessarily there's no way to use every one of those at the same time. Why?
Actually, all 751 fit into all four
Right. So you have the 751 kids that are each one of these. So every kid is in basically 4 different categories. So to be able to do a cluster sampling and use all of it would be utter chaos. Okay, so that's really where now your explanation is why did you choose that one to get the conditions of the high school? Which one of those do you think would give you the best representation? Okay. Is there another way we can do random sampling?
Stratified sampling.
Stratified sampling. What's the difference between stratified sampling and cluster sampling?
Stratified, you pretty much have population divided into strata. So strata 1, 2, 3, 4, etc., etc.
Okay.
It's just more organized.
It's more organized too, I believe.
Okay. So the big difference between cluster sampling and the hold on a second. Let me pull it up. Get the exact. Cluster sampling doesn't necessarily take into effect the percentages, where stratified sampling does. So more of what you were describing was more stratified sampling than cluster sampling. You could do a cluster sampling where you're looking classes of groups and choosing it that way. Because you remember the cluster sampling that we did was blocks in a neighborhood, if you remember right. Now the stratified sampling takes into account the percentages in there. So those are different ways that you can do it. Now, every one of those still kind of uses some kind of random number generator, right? So you still have to okay, you've broken it up. Now, how are you picking the people in that group? Or how are you going to do it? So that you have to explain that in there as well. So this is one of those questions that, like I said, there's a lot of different right answers. And it's really in how you explain what you're doing and why you're doing it that you're going to get those points. Okay? So just keep those things in mind. And why you chose which ones you chose. So the question on the test is almost identical. I just changed some of the percentages and the numbers a little bit. All right. It's basically the same kind of concept. So. All right. That's really the only question that's totally on you to figure out. The rest of them have very specific type of answers and stuff like that I'm looking for. All right. So this one, it says use the following data to create a stem and leaf plot. A relative frequency chart using limit grouping with a class width of 5 and a bar chart. This is one of those ones I would do in the order that I asked you. Okay? Because what does a stem and leaf plot do for you? It organizes all my data. And now that it's organized, I can easily do my relative frequency chart with my class width of 5, and then I can easily make my bar chart. All right? So that's really why I have it picked out. All right. This one, again, very similar to what your test of the question is. The only difference is the numbers. I actually just used a random number generator to come up with a group of numbers. So let's go through and do this. Actually, just take the numbers. We'll make a stem and leaf plot. So let's see how to do that. All right, so we got numbers from 1 to 100. So my stems are going to be 0, 1, 2, 3, 4, 5, 7, 8, 9, and 10. Now, when you make your stem and leaf plot, what I would do is I'd end up almost making 2. Your first stem and leaf plot is just going to be the numbers that they gave you, not necessarily in order. Then you have to make one that's in order for your actual stem and leaf plot. But this way, it kind of helps you organize that data, and then you have the one extra step in there. If you try to do it at the same time, odds are you're going to miss something or mix up a number. So we've got 30. So 0. We got 1, 4, 6. Probably should have done this ahead of time, but that's fine.
Yeah, you want to steal mine?
Nah, it's okay.
I think I'll pass doing it that way.
Oh, the way I'm doing it right now?
Yeah. Basically, I was doing it one by one, looking for each one.
Yeah, that's why, like, I think these are little things that'll help speed you up. Because you only have so much time to do the testing. You just have to not screw up the fact that I'm going 7-5 and I'm going to put this 5 in here. Like, nope, it's 7-5, which I've almost done a few times.
Mr. Baker.
Did I screw up already?
Oh no, I just had a question.
Oh, go ahead.
Can we use 2 lines per stem to answer this question?
Um,
Because that's what I did, and I still got. The
So-
answer correct.
I just did that. So yes, you'll still. I wouldn't necessarily do.
The 2 lines
two-
per stem.
So okay. Will I mark it wrong? Absolutely not, because it's still technically correct, and it might actually help you a little bit more in the second part of the question. For a question like this, though, you really want to use a 2 stem, or 2 stems. When the data is more compressed. So, like, if I had 50 numbers from 20 to 50. All right, 20, 30, 40 isn't going to make that big of a difference, but 20 to 25, those might make a big of a difference in there. So you kind of want to use a double stem for that type of stuff. I could see why you would want to use the double stem for this one, because the second question says in class was of 5, so it kind of makes more sense to you. That's fine. Notice the bar chart did not say it had to be in class with of 5. So you could technically have done the bar chart with the groupings like this, or you could have done it with the groupings of 5. That's up to you on how you want to do it. Both will get you the correct answer. All right. So it's really as long as you've done what I've asked you correctly, you're fine. The reason I did the class with the 5 is because I really wanted to make sure you did some more percentages in there and actually broke it down a little bit more. If you noticed, what I have right here is basically, if I turned it sideways, I have a bar chart. All right, because the stem and leaf plot basically makes you your bar chart. It's telling you how many is in each of those things, which is what you wanted to do when you're trying to create a bar chart. So there's your stem and leaf plot. I'm not going to put it in order, but you'd want to put that in order to actually make your actual stem and leaf plot there. Now, to come up with your percentages, I'm going to do a couple of them. I'm not going to do every single one of them. So we've got 0 to 4, and then 5 to 9, and then 10 to 14, and 15 to 19. So remember, when you're breaking up your class widths, they have to be 5, and they can't like overlap each other. Now, this data is discrete data. So when we're looking at doing it, we're going to do the limit grouping, not the cut point grouping. Remember, that's the difference between the two. Cut point is under 5, and then 5 and over. So that's where it breaks down. Since these aren't decimals, I don't need to worry about that. Yes.
We have to always start with 0 when we're making the frequency charts, because in some of the problems I did in the book, right?
It depends on the data. It depends on the data. So if you're looking at your first number was 16 and your last number was 93, you want class of 5s, you could do 16 through 21. It doesn't matter. In this one, I have points that are at 0 or 10 or 20, things like that. So it makes sense to do your cut point groupings from 0 to 5.
I did like 2 to 6, 7 to 11, 12, all the way to 106. So
okay,
that's
so
correct.
It could be, the problem is then you have your data skewed because you don't have numbers that are over 100. Your last number is 100.
Yeah, last number is 100. My last lower class limit, excuse me, is 102.
Right, but we don't have any numbers that are over 100. So your last one group had 0. So that could skew the numbers a little bit. So you really want to look at where you start and where you end and kind of come up with groupings that fit in all those data points. Okay, so in this case, I would probably do the 0 to 5s. If all your calculations are correct, I'm not marking it wrong. Okay. I might have mentioned a little point there, what I just basically said. So you also got to look at is make your life easier. Like we broke down the stem. You already have your stem done and broken up from 0 to 4, 5 to 9. You already done that. So if you don't have to recreate the wheel and recount things again, why do it? Make sense?
Yes, that makes sense.
So, all right, so let's do 0 to 4. I have 2 of them in there. And I think I had 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I had 50. Yeah. So it's 2 divided by 50, which is 0.04, or 4%. 5 to 9, I have 1, 2, 3, which is 0.06 or 6%. Any of those 3, I would have taken. It does say relative frequency. So actually, rephrase it. The last 2. You can either leave it as a decimal or as a percent. Either one of those. You do have to actually do the division from the fraction, though. 10 to 14, we've got 1, 2, 3. So 0.06. And 1, 2, 3, 4, which is 0.08. Okay, so that's basically what I'd be looking for the entire thing. And like I said, you can set your bar graph up into the 0 to 9, 10 to 19, just like you did your stem leaf plot, or you can do it out in the groups of 5 if you want to do that way as well. Yes.
So for the stem and leaf, I organized all numbers first, and then I did the stem.
That's fine.
Okay.
So the stem and leaf plot that I have on my screen right now is not what I would want to. That's not what I want to see. Okay. I want to see it in order. Okay. So what I was showing you there is that's a quick way to do it first, because in essence you did it. You just organized all the numbers out. I did it in the stem and leaf plot to organize them. Either way works. So no matter what, you kind of have to organize the numbers some way. I just chose to do it that way to help you. So. But yeah, the stem and leaf plot that I'd expect to see on the test would be one in order, because that's a proper stem and leaf plot. So, and you can do it in the one or the double. Yeah.
I'm assuming we can bring scrap paper.
Absolutely.
Yeah.
No, actually, I'll have scrap paper for you. So yes, I will have scrap paper. And every question's only at 1 page per question, just like the actual review sheet. So you have that entire thing and the back of the sheet too. So, but yes, I'll also have some scratch paper and stuff like that if you'd like some extra stuff. And I'll bring my stapler so you can staple it all together. All right. Next question. For each of the following problems, state whether the data is best described using mean, median, or mode, and explain why. So, A, cause of accidents. Would you want to do this as mean, median, or mode? Why? It's what? It's qualitative. That's right there. That is the number one reason why you cannot use mean or median. It's not quantitative. It's qualitative. The only one you can use is mode. And also, that's you'd want to know the most. So in that case, that would be mode. So A is mode, and it is because it is qualitative. B, birth weight of a child, mean, median, or mode.
Median.
Why? Just because I answered that question yesterday.
Because it's aimed at the most central weight of a child, and it is not going to be affected by extremely large or small sizes.
Yes. So remember, whenever you have, you could have things that would skew that information. Mean kind of has a tendency to get skewed by that. So median is typically used for this situation. The example that I sent him yesterday when he asked me this question was, I found the largest baby ever born was 22.9 pounds. I do not, I feel very, very sorry for that mother, and I'm hoping it was a cesarean. But yes, 22.9 pounds. But then you also have the other direction where you have extremely preemie babies that are like literally under a pound. So each of those situations can drastically skew that mean and change your viewpoint of it. So median makes a lot more sense to that. Vaccination status of a country. So why? Why? So hold on one second. We'll go with mode in a second. Why mean?
Because you get the percentage of the vaccination rate of the country, so you get people divided by the population.
Okay, but why mode? Could be. It is numerical, right? Because it's going to be a percent. So depending on how you look at it, that percent's really an actual representation of yes or no. Okay, so these are some of the, like this is one, depending on how you want to describe it, like explain it, it could go either direction. If we're comparing different countries, then mean or median might make more sense because now you're not looking at yes or no, you're looking at the percentages and comparing that. Where if you're just looking at a specific country, yes or no, that is qualitative, and mode would don't be the only one that would make sense in that situation. So depending on how you want to explain it, depends on how you get the answer. Okay. So I could see mean or mode for that one. Family income. Yes.
Question on that last one. So if we put mean, but we put a really good explanation,
You'll get it.
would be wrong.
No. That's what I'm saying. It's like, so when I'm asking you to explain why, that really is going to be the bigger piece on if you get the points or not. Like mean, mode, or median, it's basically a multiple choice. And I honestly, you'll notice there's no multiple choice because I hate multiple choice questions. It's like, because there's end up being a lot of games played in it to try to figure out what's the right answer instead of actually understanding. The why is really the piece here. So if you can explain why you chose that and what you said makes sense, you're good.
The vote would be more correct, but we could also.
And again, it depends on what you're looking at. Like if we're comparing different countries, Mean totally makes sense because now you're using that percent to compare countries, which is what we did. They're doing now when looking at COVID vaccination stats. They're comparing countries around the world and saying what's going on. So mean or median totally makes sense in that situation. If you're just looking at a specific country, mode makes sense in that because now we're just looking at are you vaccinated or not. Now it's a qualitative data, not a quantitative data. So that's where that how you interpret that actual question. All right, family income.
Median.
This is typically median. This is actually one that they use quite often. This one's median. All right. So we're over halfway through the test already. Are you guys feeling confident, worried so far? I think it's like I said, it's more of understanding, like explaining. Like it's not just here's a number. That's why, like, out of all the math classes, this one's a little different than your traditional like algebra type math class where there's one right answer. All right. It's not necessarily there's one right answer. Some of these questions, yes, there's one right answer. Like this one, there's going to be one right answer. But it's more about understanding what you're doing and how that information is used. Okay. And that's really that explanation. That's really that description of the data and stuff like that that comes into play. So understanding that I think is more important than having a specific one. Like this is the answer. That's it. I'm done. If it's not that way, if it's not my way, it's the highway type thing. So I've never been that type of teacher. It's like, if you can explain a good reason why, we're good. All right. This one, you're going to get a set of 20 numbers, and you have to find me the mean, median, mode, and standard deviation of it. So how do I find the mean?
Kind of all the numbers and then divided by how many numbers there is, so 20.
Yep. So let's add them all up. That's fine. The wonders of a Desmos calculator. Oh, sorry, I made my screen smaller so this way I could actually type in the answers and see the numbers at the same time. Why am I doing it that way? I'm dumb. Let's just do it this way because it's going to give me all those numbers anyway. And I have to do that anyway. Remember, whatever you're using to do this, make sure you can see all the numbers you were typing in so you can go back and check them and make sure you didn't type any incorrectly because it is really easy to mess this up when you're going through a whole list of data looking back and forth. All right. So the standard deviation calculator, which you have to do anyway, gives you your mean. So it saves you one step there. So my standard deviation for this one is, I don't think I said what it is, so 3 decimal places. So 28.558 is my standard deviation, and my mean is 52.25.
To figure out if it's a sample population.
So if it's a sample, they would have to tell you that this is the sample of something. So if they don't tell you otherwise, you assume it's a population because you have everything. So
I just remember.
yeah. If I don't tell you, assume it's population. All right. So we have our mean and our median from there. Or sorry, our mean and our standard deviation. Median, you got to put the numbers in order and find the middle. So did somebody do that?
It's 53, 58.
So it's 53 and 58. So since it's even, we're going to have two of them. So what do we do with those two numbers? Add them up and divide by 2. So 53 plus 58 is 111. So it's 55.5. Not that this question is asking this. Is this skewed to the left or skewed to the right? Skewed to the left. Remember,
Yeah.
it's the direction the mean is pulled. So the mean is pulled lower than the median. So this is skewed to the left. All right, what's our mode?
11, 80, 100.
Yep. So I have 3 modes. And yes, that is possible. And again, I used a random number generator for these. So even on the test, it's randomized. So it's possible that there is no mode. There's possible that there's multiple modes. It just depends on what numbers they gave me because I didn't even actually look at the numbers. I just copy pasted it in. So, all right. Any questions on those? Okay. We're almost done. We got 2 questions left. All right. So number 6 is looking at the mean and the standard deviation. So this is looking at a standard bell curve. So find the range of ages that would include at least 68% of all millionaires. So remember our bell curve? It is 68%. And then, so that's 1 standard deviation away. And then we have 95%, which is 2 standard deviations away, and 99.7%, which is 3 standard deviations away. So my mean is 35.2, and my standard deviation is 3.6. So we're going to add and subtract from that. So 35.2 plus 3.6 is 38.8. And if you just want to keep going down that side, you could. If we added it again, we would get 42.4. And if we added it again, we'd get 46. Yeah. And then if we did the other side, we'd subtract. So 35.2 minus 3.6 is 31.8. No. 31.6. We do it again, we get 28. We do it again, we get 24.4.
Yes.
Okay. I would do that for this. We now have all the data to answer all 3 questions. Okay? Yes.
What we do, do you want it drawn out like this?
Yeah.
Or?
I don't care how you do. This actually isn't even part of the answer. This is literally the work to get the answers. But the nice thing is by doing that, you now have all the information you need to answer all 3 questions. So that's literally like your work. So I don't care how you actually do it out so you can see how it is. I typically draw it out like that, but you don't have to. You could also make a line and put the lines above it. Yeah.
Just a quick question for
Yep.
6C.
Hold on, I haven't even answered 6A yet.
Sorry, my bad. Okay.
Let me answer A
I'll wait.
first.
I'll hold that question. Sorry.
Okay. All right. So 6A is asking us to find the 68%. So that would be that. The range of ages would be 31.6 to 38.8 years old. Okay. I know this data means absolutely nothing. I completely made the numbers up. Okay. So that would be A. B, what percentage of millionaires are between 28% or 28 and 42.4? We have that. The 28 is right there, the 42.4. So it would be 95%. So A is 31.6 to 38.8. B is 95%. All right, now question C. What is the maximum age that would cover approximately 84% of all millionaires? We don't have 84% on the screen, do we? No. I don't want a range. I want the maximum number. So I'm only looking for one number for this one. Anybody want to take a guess at what number it is? Yes.
I would like to guess it is 29.6 years old.
Okay. I've got to ask how you came up with 29.6 years old.
So I multiplied the mean age by the decimal form of 84%, which is 0.84, and I got 29.568.
Okay.
Then I rounded that number to get 29.6 as
Okay.
my final answer.
All right. What's the mean represent?
The average age of the millionaires.
Okay. So, and in a bell curve, the mean will be exactly where on the curve? In the middle, which would mean how much is below the mean? 50%. So your number is less than the mean. So your number would show me less than 50% of the values. You found 84% of the mean. So you found 84% of 50%. So, okay. Which is fine. It was a good try. Anybody else want to take a guess? Using the information I just said should give you a clue on where I'm going with this question. Yes, this question is designed to be harder than just picking a number. I can't make the test so easy that everybody would get 100.
38.8.
Yes. Why?
Because the mean would be at the middle point. Take 68 and divide it by 2, you get 34.
Yes.
So after the first.
So
the mean one.
here, I'll show you the. And I actually did show this last class, but let me show you this. Copy image. So this right here, right in the middle, was 35.2. And then this was 38.6, right? No, 38.8. So if we start here at 0 and we go this way, this part right here is 50%. If we then add that number is the max for 84%. Yes. It's just it's a more accurate representation of the 68 cut in half. It's actually not exactly 68%. It's close. This is just the first graph that I found. So if you take 68, cut it in half, you get 34 and 34. So you got to remember that the bell curve cuts in half. That's the mean is the middle of it. So that cuts 50% on either side. So if we're looking for the maximum value for 84, that's going to throw you into that spot right.
I still don't understand how you got 38.
Because it's one standard deviation above the mean. So if you look at the very first thing we did,
Yes.
we did the mean was the 35.2, and then we added 3.6 to get 38.8.
Yes.
So that's one standard deviation above the mean, correct?
Correct.
Okay. So now if we look at this, that right there is one standard deviation above the mean, correct?
Correct.
Okay. So from here all the way over, from here to here is 50%.
50%. So
And then I'm adding another 34% to that.
Hold on. So the 50% that's on the left side of the mean would be representative of the 3 standard deviations below the mean.
Well, technically the
I
infinite standard deviation, but yes, that's right. Yeah. It's everything from 0 up to 35.2. It's 50% of all millimeters. And then if we go one standard deviation over, we got to the 38.8. And that is an additional 34%. Because this block right here is 68%. And that's 34 and 34. That's
So that dark blue block and the other dark blue block
equals 68%.
equals 68.
One standard deviation.
Okay.
Okay. Yes, that question was literally designed to make you think about how that bell curve works. Okay. Any other questions on this one? Okay. Last one. All right. So what's the first thing we're going to have to do to this data? Have to put them in order. Yes. Huh? That would actually be ideal, but it doesn't have to be. Because when you're doing your quartiles and stuff like that, they don't necessarily have to be the exact values. You're going to make a number line for those. So, but yes, the first thing you're going to have to do is somehow put these numbers in order. So let me actually do that. Okay. And now order them. Much better. So can I quickly do this?
Download the program.
That's literally what I'm using. Yes.
Okay. I was like, is that program
Yep, I'm using Excel. I was just trying to see if I could actually quickly flip it over to the other direction. But I know there's a way to do it. I just can't find it quickly enough. It's fine. Actually, let me do this in little smaller chunks. All right. Okay, so here's my numbers in order. Okay. So we're going to make a number line. And let's see, it's going from 0 to 85. So we'll make the middle 45. And let's do by 20s. 65, 85, 25, 5. When you make your number line, it doesn't have to be exactly based on the numbers that are there. It just kind of has to be semi standardized. So I decided to count by 20s. All right. So let's find what's the first thing I have to find? I think I got to find my median, right? So the first thing I have to find, so it says find the quartiles of the data. So to find the quartiles, I need to find the median, the middle number first, because that's going to split the data in half. And then I could find my Q1 and my Q3. So my median, if you noticed, I cut these in groups of 10. So there was 39 numbers. So it would be the 20th number would be the middle. I cut 19 off of either side, which in this case is 44. So if we were to count backwards and we just sliced them off, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the only number left would be 44. All right, now Q1 and Q3, we're looking at each side. So if we look for the Q1, we're just going to do the same thing on this side. So Q1 is 32.
So to find Q1, it's just another middle.
It's the middle of the lower half. Yep. Yes.
Don't you have to count like 44 also?
No. Once you use it, you don't need it. If it was even, I technically don't use those numbers. Yeah, it was like double it. It doesn't change the actual answer. Yeah, if it's even, you don't actually use the numbers, so because you're going in between the two numbers, so you'd use those numbers. If it's odd, you don't need it. I did notice that's the way the book explained it, and it's funny. It's the only book that I've ever seen explain it that way. So, No, so yeah, so if you're gonna double it, you'd put 44 in both groups and do the same thing. Yeah, I've always literally taught is if it's odd, you just cross the number off and you don't use it again because you've used it. All right, let's do the upper group. So my upper one is 52. If you follow exactly like the book follows and it changed, I'm not going to mark it wrong. So it's like I know what you're doing. All right, so my median is 44, my quartile 1 is 32, and my quartile 3 is 52. That's the quartiles. Okay. If you want to then put those on the bar graph or the box and whisker plot as you're doing it, you can. So I have that's 44. Then we're going up to 52, which let's say that's about here. Then we're going down to 32, which let's say that's about here. Again, it doesn't have to be exact. You're drawing this out by hand. I'm fine with it not being exact. All right, I think the next question said, what's the interquartile range? What was my interquartile range?
20.
Yeah, remember it's Q1 minus Q3 minus Q1. So in this case, my interquartile range is 20. Your 5-number summary is your quartiles, Q1, the median, and Q3, and the min and max. So my min is 4, and my max is 83. So that's your 5-number summary. Yes.
Nothing in my mind.
Okay. Yes, one of them is an outlier, but it still doesn't change your 5-number summary.
The 5-number summary is just Q1, Q3, Q4.
No. Q1, Q3, the median, min max,
Okay, but not Q1.
not the IQR.
Okay.
So your 5-number summary is those 5 numbers. Yes.
I thought the max did change.
It does in the actual box and whisker plot. It doesn't in terms of the 5-number summary. That's why I'd asked you after that question. If you did it, it's fine. I'm not marking it wrong. But when you list your 5-number summary, it's just the 5 numbers. You're going to include your backs and stuff like that in it. When you write your box and whisker plot, that's where you put the star as an outlier. All right. Do I have an outlier in this case? Question. So how do I find my outliers? It's 1.5 times my interquartile range, right? So my interquartile range is 20. So 1.5 times 20 is 30. So I'm adding and subtracting 30 from my Q1 and my Q3. Sorry, I'm trying to do it all on one screen so I don't have to keep switching screens. So my lowest number would be 2. Do I have anything lower than 2? No. So my min is correct. That's 4. And if I go 30 plus 52, I would get 82. So I do have a outlier there. My outlier is 83. So I'm going to go up to 82, and I put a star at 83. And there's my Box-and-whisker plot.
So the 1.5 times 20 equals 30, what's that for?
That's going to tell you if you have your outliers. So you add that to the Q3. That'll tell you the maximum value that you should have. Anything higher than that would be an outlier. In this case, 30 plus 52 is 82, and I have a value called 83. If I go the other direction, 32 minus 30, it goes me down to 2. My lowest number is 4. So that 4 is not an outlier. The data that you get to do this will be very similar. You will have an outlier. It is a random numbers, but I added numbers in there afterwards to make sure that it worked out that way. And it's designed to make you understand that the value of 30, because if you looked at that data, my guess is you'd have said the 4 was an outlier if you didn't have to do the calculations out and not the 83. Because there's numbers closer to the 83 and that 4 is way lower. It's just because of the way the interquartile range works and where most of the data is, that 4 really isn't an outlier. It's close. So that's your test. You'll be fine. Like 99% of the reasons you guys don't do well on tests is you get into your head. Don't get into your head. You have an index card. You've practiced it. There's not a ton of calculations on it. All right. Remember, find a calculator that you can do your standard deviation so you don't have to do that. Maybe find a calculator or something online that'll sort your numbers for you so you don't have to do that part. Like, you're more than welcome to do that. That's fine. I will be here, like I said, at 9 o'clock. So if you want to get a little extra time in, you can. We can be in here till 10:45. The next class doesn't start until 11 o'clock. So, yes, they will be. As soon as I finish saving the things and upload them in about maybe 45 minutes. So, yeah, that's fine. They'll be up there. The video will be up there too. So you can go back and listen to it. Okay. Any other questions? All right. You'll be fine. Don't stress out. Stress causes you more trouble than it's worth. And remember, worst case scenario, you bomb this test, you can make it up on the final. So